Okay, so today we're going to talk about transformations. This is a review of our previous unit on the absolute value transformations, and we're going to need this when we move forward into our quadratics unit next. So the general graph of an absolute value equation, y equals the absolute value of x, if you remember, absolute value forms a v. So we're going to be looking for the v. And if we think about our points, if we plug in 0, the absolute value of 0 is 0. If we put 1 in, the answer would be 1, 2, 3, 4, and so forth. And so we have this linear look on this side. And if we go to this side, if we put in -1, the absolute value -1 is also +1. -2 is +2. -3 is +3. And that's where we see that v. And I always say, remember, because absolute value starts with a v. So that is our general form of an absolute value equation. That is called the parent. Okay, so we're going to have the parent function, and we're going to now talk about how to transform that function. So the first type of transformation we're going to talk about is the h. And this is a transformation that happens within the absolute value sign. Okay, and h, I always like to think about, stands for horizontal translation, or sometimes you'll hear shift. And if we have an x minus h, it's going to shift right h units. And if we have an x plus h, it shifts left h units. The next part we're going to talk about is the k. So k is the part after the absolute value signs. Okay? And k is the vertical translation or shift. And if k is positive, or it says plus k, it's going to go up k units. And if k is minus, it's going to go down k units. And then the last part we're going to talk about is a. Okay? And so a is this term in front of the absolute value. And a has two things that we have to consider. If a is negative, okay, the graph reflects across the x-axis. And then also a is a vertical stretch or shrink. Okay, so it's going to vertical compress if a is between 0 and 1, and it's going to stretch if a is greater than 1. So those are the different transformations that will happen on our graph of our absolute value. So we're going to look at the first example. So this is the we do part. Okay, so without using your graph and calculator, describe the transformation from the parent function and create the graph. Okay, so this first one we've got it's inside the absolute value. So this is a horizontal transformation. That's why I'm making it purple kind of to match the colors. And so it's x minus 5. If we look here, x minus 5 is a shift right 5 units. So we go to our original start, if we think of our parent function at 0, 0. We're going to shift the graph 1, 2, 3, 4, 5 units to the right. And we're going to start there. And we're going to follow the same pattern. It goes up 1 over 1 this way, and up 1 over 1 in this direction. And there's the graph. Okay, looking at number 2, this again is inside the absolute value. So this is x plus 2, and it's going to shift because it's plus left 2 units. So I go to the 2 units to the left. Again, that's a starting point, and we're going to follow the same pattern, up 1 over 1 on both sides. For number 3, we have two things going on. We have an A and we have a K. So we're going to always start with our K. So K is -4, which means we're going to shift down 4 units. So 1, 2, 3, 4. That's our new starting point. And then A is equal to 2. And with a linear graph, this is like the slope. So it's going to stretch vertically. And instead of going up 1 over 1, we're going to go up 2 and over 1. The slope is now 2 instead of 1. And you can do that in the other direction too. And you can see that it stretched or got narrower. And then the last one is a +2 outside the absolute value. So that is a vertical shift, and it's going to shift. So k equals 2 is going to shift up 2 units. So we go up 2, and then this has A is 1, so we're going to go up 1 over 1, and up 1 over 1 the other direction, and there's our graph. So translation up or down, translation to the left or right here, and then again A is going to stretch. So I guess I should have made that one in black. We want a slope of 2.